This is a quick recording. When we write certain functions, we are keenly aware that the code may be the same, but the data types are different. Consider, if you're adding two integers, you must pass two integer arguments. If you're adding two floats, you must pass two float arguments, but the code where you perform the addition is exactly the same. So I want to introduce you to the ability to write code that works regardless of data types. These are called function templates, and they are basically a pattern for creating function bodies that differ only in the type of data they manipulate. Your alternative is to write an integer add, a float add, a short add, a long add, etc. That is, write multiple versions of the same function where you rely on the compiler to do overloading to distinguish the function that's actually being called. So here's an example. If I want to swap, you basically pass two variables and you're allowed to pretty much exchange the values that they have. And the code is exactly the same. Notice that from this point on in this function, the code is the same as it is in this function. So a template allows you to say, the code for swapping is I need a data type, I need a variable, and here's the statements I write. And the data type that I use, I want to use the data type pretty much as a parameter when I write my pattern. The key to defining a template is the header here, where you're declaring that the code that follows is a template. And in the template, instead of using a data type, you're going to use the parameter t. Okay? Now, how does that work? Well, what you have just created is a pattern for code. It is not actually code. What happens is when you see a call to the code, the compiler says, aha, I have seen. What just happened? When you have a call to the code, the compiler says, the data type here is an int, the data type here is an int. I need a function called swap that takes two integers. And the compiler will say, whoa, I just saw a template declared for swap, and the template allows me to vary the data type. So the compiler says, I need to actually turn this template into some code that works for an integer. So basically, this call will result in some code being generated by the compiler that works on integer arguments. All right? The process of making code that matches the data type and using the template to do so is called instantiation. And instantiation basically generates code where an actual data type is used instead of the data type parameter t. All right? If your code does not contain a call to the function, there's no extra code generated. So the template itself really uses no memory in your object file. The template exists during the time of compilation only. All right. So that's about all we need to see. Let's take a look at an example. So let's take a look again at a swap. If we're doing an integer swap, we need to say integer, integer, integer temp, and we do that. In this code, we're writing a template for swap. Notice that up here, this code is a function. This code is a function template. And a template is a generic or a general solution to a problem where you kind of factor out the data type. Now, I want you to notice a couple of things. If you have a struct is just a variable that has many values in it, and you can swap those. You can swap what's in one record with what's in a different record. That's pretty easy to do. So we have different data types. We have integer, float, string, bool, and we have a struct. And this code demonstrates that the one generic function here, swap, can be called can be instantiated for each of these 5 different data types. And when we call the swap function, it will perform correctly. So we're going to call it with the string bool struct. So let's kick out of here and just run that code. Template swap ts. And we're going to run it, and we see that if I call the function for an integer, it gets instantiated and the function works. If it's a float, even if it's a struct, before I call this, a struct has the number 7, the word slow. One has the number 4, the word dog, and after the swap, they have in fact been exchanged. So let's take a look at one more briefly. We're going to look at the max. And again, I'm passing it different data types, an int, a float, a char. And the max function is what we would normally write. If I got 2 things to find the max, if the first one is bigger or the same, I can return it. Otherwise, I return the second one. And that's all we're doing here. We're making it a template by putting this header and by taking the data type and making the data type a parameter t. Reminder, the parameters must be, when you write the template, the parameters must be passed by reference. Must be, okay? All right, and with that, we will see that it's not the swap, the max thing will work, okay? So I think that's all. Why are we doing this? Later on, when we write functions for sorting and searching, doesn't matter how sorting and searching works. The algorithm is exactly the same, whether you have a string, whether you have integers. All of those things are independent of the data type. So we're going to write some functions that will sort once and for all. And if we make them templates, we can use those functions no matter what the data type. Okay, with that, we're going to stop.